Okay, thank you. It's really a great pleasure to be here, and I just want to congratulate Gergely and the organizers for putting together a really great conference. It's like coming to a really like a USR number 2. So I think for the people who join us in the bar in the evening, buy them all a beer. Okay, so my name is Mark. I'm going to talk about a package that I've developed together with a colleague of mine, Edwin de Jonge, who couldn't make it today over here, called Validate. And I'd like to start with a small example to illustrate what the package is for. So suppose I hand you over a file. You're all analysts, I guess, in the audience. And I hand you over a file and I tell you, okay, it has 2 columns. It's a CSV file. The first column is age of person, and the second column is income or salary. So the minute I tell you this and I give you this file, you already have a couple of expectations, right? For example, you expect both columns to be numbers. You probably expect age to be non-negative, 0 or more. And maybe the same about salary. Most people don't enjoy negative salaries. And if you know something about labor market, you might have some more complicated expectations. For example, persons below a certain age, for example 15 years old, cannot have a salary, so it should be 0. And so these expectations couple the different variables in your file. And the chances are that when you start analyzing a file like that, and those expectations are violated, then the results of your analysis will also be incorrect. Right? It's garbage in, garbage out. So in general, and this is only for expectations for like 2 variables, but of course if you have many variables, you will have many expectations. And in general, you would like to check them somehow. So the purpose of the package is to make checking your data against such domain knowledge as easy as possible. So we distinguish between technical demands and domain knowledge, but they're not really that different. And so what I want to talk about in this talk is give you sort of a flavor of the package, showing the basic concepts and workflow that we use. Really very simple, I think. And after that, I just go through a number of examples, showing the syntax, the sort of DSL we defined, showing you the range and type of validation that you can perform on data using this package. And I'll end with a short outlook. So this is the basic concept. We have 3 or 4 concepts basically. You start with rules. So all these expectations that you have about data, you can express them as a short rule. Age must be positive, income must be non-negative. If age is lower than 50, salary must be 0, things like that. These are rules and we store them in a validator object. The data just comes in the data frame at the moment. And you confront your data with the rules, and what you get is a bunch of results, and they're stored in a validation object. So we chose to store this in an object rather than giving you a raw value, true or false or something like that. Because just like when you're building linear models, there's a lot of output that may have different dimensionality, and then it's just convenient to store it in an object and build some functions that retrieve data that's useful for you. So those are basically all the concepts we have, and this is how it works. I will start with showing you a little bit of data that I'm going to use in the coming slides. So in the validate package, there is a file included, dirty data included, and we had to include some new data because all the data, example data in R is so perfect. It's really hard to find dirty data. It's really unrealistic. So anyway, we put some a small example data set in there, and it's shown 3 columns here. So these are data on companies. I work for the Central Bureau of Statistics, so we have some data on companies. And then so we ask for turnover, other forms of income, and total revenue. And then just by looking at the first 6 rows, you can already see some strange things. There's data missing. There is some other revenue, some income that's negative, which is strange because it's income. And one other thing you might expect is that turnover plus the other revenue should add up to total revenue. And so there are lots of things that you can check. Okay, so here's how to do it in validate, or one way to do it. First, you just store all the rules in a validator object using the validator function. So turnover larger than 0, turnover plus total revenue equals total revenue, and so on and so on. Just comma separate it as many as you like. You can confront that with your data, and then there's all kind of analysis you can do on the outcome of this call. Here I show a summary, which gives a short summary of everything that's validated. So I have two rules, rule 1, rule 2. They are automatically named V1 and V2, but you're actually allowed to define your own name to make it easier to recognize the results later. 60 items, that is 60 records, got checked. 56 of them passed the check, 0 of them failed. A couple of them could not be checked because there's data missing. So I'm checking whether turnover is larger than 0, but if turnover is missing, I cannot perform the check, so you get NA back. And actually this is an option, you can also set that to false or true, or whichever you like. But by default you get NA back. The check could be performed without errors or warnings. And here's the expression that was used to perform the check in the end. So the second line is exactly the same. We have some less passes, fails, a lot of NAs. It's not strange because this one concerns 3 variables, so more 1 NA and the whole row cannot be checked. But another thing I want to point out here is that we define an equality rule here, but to check that exactly on numbers is usually a really bad idea, right? Because if these numbers are computed somehow, there's bound to be some machine rounding, and exact, bitwise equality is almost never the case. So the validator, the validate package is able to recognize these kind of linear rules, numerical rules, and with some assumption, of course, and then it turns it into this and just checks the left-hand side and uses this sort of epsilon, which of course is also configurable. Okay, another thing you can do is plot. So we have this CF, which is the confrontation object, validation object. You plot it. Here there's only 2 rules. On the x-axis you get the number of items. Green means okay, passed. Yellow means couldn't check it, and red means of course failed. So if you have, even if you have 20, 100 rules, you just have bar plot and you get a really neat overview. A lot of red, bad, a lot of green, good, a lot of yellow, we don't know. So I think it's very easy to, if you write markdown reports and you have the same data file, you have to check it like every week, for example. It's part of like a sort of infrastructure for a dashboard. Okay, if you want to extract every result of every rule from every record, then that's possible as well. The function values extracts the matrix with all the rules. Now, I'm going to emphasize later is that here I am only showing you rules that can be checked record-wise, but it's not necessary. You can do much more complex things than that. Okay, here's a shorthand. If you think that defining rules and then using confront takes 1 line of code too much, we also implemented this check that rule. And so the null pipe operator is very popular nowadays. So actually all our functions fit in that piping operator. So you can just do it inline. Okay, another feature is everything I showed until now is you do it on a command line, more or less interactively, or maybe in a script that you write in RStudio script editor. But it would be much nicer if you can store the rules in a file and then reuse them. And another really important way to use that is I have a file of rules. I can send it to the person who sends me the data and ask him, can you check it? And please, before you send it, make sure all these rules are validated. So it's also a way to, I think, to communicate data quality standards among analysts or data suppliers and data consumers. So what you can do is just write those rules in a plain text file, just like you would write an R script, and then with validator, you just read it as a .file argument, and that's it. We have a second format, a YAML format, where you can add a lot of metadata, names, descriptions, things like that. timestamps. So the rules can have some metadata by themselves. Maybe you want to attach a version, or like the name of the person who invented the rule, or make some kind of story why the rule should hold, and under what conditions. So all that can be annotated if you do it in a more formatted style. Not shown here. Okay, for the rest of the talk, I'm going to just show you a bunch of examples of rules to show you the range of types of validations you can think of that can be implemented in the package. So, a very simple technical check whether a variable is numeric. So, any function that starts with is dot is a valid validation statement. When we read in the rules that you define using validator or read it in from a file, all the rules get checked, and we check whether it actually will evaluate to logical. Right, so we're not allowing you to read in rules that are not validating rules. Not any R statement can be put in here. It has to be something that evaluates to logical. R is very flexible, so we have to make a few assumptions, but until now we found it pretty stable. Check whether a variable is there. So, suppose you want to know if the variable total ref is present. You can use the dot syntax. It was quite recently introduced. The dot means the whole file, the data frame itself. And so if you do names dot, you get the column names of the file, of the data frame, and you can check whether the name total ref is in there. Or you can do a check on the number of rows, for example. So rather than computing variable by variable, you can also do a computation on the data set as a whole and check metadata, dimensions, names. Here's a little bit more complicated rule I was talking about. Suppose you're looking at the mean turnover, and it must be 20% of the mean total revenue. Then you can compute the means divided by the mean of the revenue, and then check it against some limit. So the point here being is you can actually put any kind of R calculation here. You can do a linear model and check the size of some beta coefficient or something like that. Anything that computes in R is valid. What's important here is that it's compared with something. That makes it a validation. Otherwise it's just a computation. This is that makes it validation. So that also is a little bit of the tip of the iceberg, like how we check these things. We implemented a little bit of syntax for checking conditional statements. For example, if turnover is 0, the total revenue must be equal to 0, or if a company employs staff, the staff cost must be higher than 0, for example. So this is a normal R statement, but what the package does is it executes it for every record. So we vectorize it and then evaluate it over the data set. So it just makes it a little bit easier to write. So syntax is sure. An interesting case is this one. These are called functional dependencies. That's a concept that comes from computer science, or basically database theory. And it's a very compact way of expressing that, for example, if two records have the same zip code, then the city and the street name must be the same as well. And this is sort of a mathematical construct. You can do some calculations with it, a little bit of algebra. This means two records have the same zip code. They have to have the same city name and the same street name. We've implemented it like this. Implement this, it will go all over the file and check the duplicates and see if those rules hold. Then there are a few things that add programmability. Because if you have a lot of rules, you run into the chance that you're writing the same code many times. So we've implemented sort of a macro operator, transient variable that's defined and then later thrown away. You can compute a median, for example, like this, and then store it in a temporary variable called net, like this. And then use it in a rule further along the line as if you would use any other rule. So for large rule sets, especially when they're in a text file, this makes it really convenient to reuse computations a number of times. Another thing, also kind of sure that we implemented the variable groups. So often what we find when we have data sets with a lot of variables, a lot of those variables need to satisfy similar rules. So all of them have to be between 0 and 100, for example. You have a bunch of percentages. So in R, in the default case, this would mean for every variable you need to define 2 rules. Larger than 0, smaller than 100, for example. So what you can do is define a variable group. Variable group using the var group function and this colon equals operator. And then these rules just get multiplied over all these variables. And you can also combine rules with each other, then you get a Cartesian product of rules. So it's very general. But I guess it would be a bit hard to interpret in that case. And then finally, I think referencing other data sets. So everything I told you up till now works if you validate with a single data set and everything gets checked within the data set. But there's a good probability that you have the same data set this year, this week, and next week you get a similar data set again. And you want to check, oh, didn't things change like too much between them? So you can actually call it and call confront and add reference data sets. And you can reference them just with the dollar operator, just like you would real basic R. So I think the syntax was designed to be really close to what you know from R, and we just try to analyze and evaluate it a little bit, make it a bit easier. And then there are several ways to do this. You can use lists, environments, or data frames. Data frames probably the most common. So these are a bunch of features I didn't have time to talk about. How much time do I have? 4 minutes? Okay, then I also want to say that all these functions that you saw have been implemented in a really generic way. They're all S4 generic. So at the moment, we have implemented everything for data frames as a data storage format. But the plan is to support table objects, perhaps database connections, and also data table in the future. But we have to look under the hood how the engine works then. But everything is set up in such a way that we can actually, technically quite easily do it. It's more a matter of time. Okay, so what I didn't show is you can really manipulate validator objects. The rules for us are really objects of computation. So you can select them, annotate them, remove them, add them, analyze them. You can, for example, ask from a validator object which variables occur in all these rules. So you can see, okay, these variables, there's at least some kind of check, and maybe there are variables that are not checked at all. And sort of analyzing your rules, your rule set. You can summarize them. The YAML format, I think I already mentioned. I think this I mentioned also. And there are 2 vignettes in the package, one introductory and one that goes really deep into rule files. Because we try to put in a lot of programmability. For example, when you have a set of rules in a text file, you can have that text file include other rule sets, like you would in any other programming language. But actually go through the whole stack of inclusions and do the rules in that, read the rules in that order. So an outlook. So for us, what we want to do is more rule analysis, more programmability. For example, group-wise validation, and we haven't done it yet, grouped. The metadata specification, we now use YAML, but it would be very nice if we could do it with Roxygen. It's very close to what people who write packages, and I think it's more user-friendly. And the last thing I would like to say is that for us, the validate package is really the bottom of a stack of packages that we're developing for data cleaning. Because finding out that your data is not satisfying all your desires is one thing, but then you have to do something with it. You probably like to fix it. Missing values need to be imputed, violated rules must be fixed somehow. So we have a whole bunch of packages. Some of them are on-prem already, and some of them are still under development. For example, the deductive package can use the rule set and see if better values can be derived from the rule sets. When you define rules, for example, profit plus cost must equal turnover, and I know for some reason that cost is wrong, and from the other 2 variables I can derive what the one that's wrong should be. And then the deductive package has a bit more fancy algorithm, of course, but it can do things like that. That's one example. If you're interested, please have a look in our GitHub data cleaning organization. There's a bunch of packages there. And with that, I hope for your attention.